These talks always start with the same standard disclaimer. This is all for test purposes. Don't just play nicely. Don't use or abuse it for world domination, minor theft, grand larceny, other things. The rough plan for tonight, how we're going to be going through this thing. Start off with the introduction, which you're already listening to. Then we're going to move on to a quick overview of Salesforce and how that works. Moving on after that to a quick preliminary look at SOSL'ed, the language, the query language we'll be looking at. And then a discussion of how injection works in that language and in websites built on top of Salesforce. And then we'll work through how to find instances of SOSL injection, whether you code review or application testing. Move on to how to exploit that, and things you can do in a code review and app test situation. And obviously, because we're nice people, we'll look at mitigations and defenses and the proper outcomes of these things, and conclusion at the end. Okay, I'm Nick Dunn. I'm sure some of you know me and few people here who don't. Originally started working in secure coding and software development. Got very attracted by the idea that breaking things was more fun than building them. Became penetration tester and code reviewer, and eventually moved into security consultancy in a more general way, where I still work in secure code review, penetration testing, and various other standard security fun. Few important things to cover at the start is like what this talk is and isn't about. I'm going to be discussing a vulnerability that can happen from within Apex and Java code that interacts with Salesforce and is used to build Salesforce APIs. I'll be covering how to find that and locate it in a test situation and code review situation. I'm going to be like looking at this because when I first found the issue, I couldn't find it documented properly anywhere. Couldn't find any payloads online or how to test for this, and couldn't find any nice easy copy paste exploits that I could use. I'm going to give you a few examples. The key part at the bottom there are no 0 days in this talk. It's not a talk about Salesforce. It's just a talk about the language that interacts with it and how that can be misused or misconfigured. So any vulnerabilities that we're looking at are most definitely external coding issues, not Salesforce issues. Just to reiterate and clarify that I'm not a Salesforce expert. Having established my lack of knowledge about Salesforce, I'll give you a patronizing explanation of what Salesforce is. It's a CRM system, cloud-based, and it sort of facilitates website creation, helping people to manage customer records, sales records, and it has this standard sort of interesting description of itself and standard terminologies that are used. One of the things that's going to be important to us as we look through this stuff is this idea of create, read, update, and delete, which is their self-appellated description. For the way object-level security in Salesforce is referred to. Different Salesforce users have different permissions on different Salesforce objects. And in line with this weird terminology, an object in Salesforce is not an object as you might understand it from normal programming languages. Salesforce looks a bit like this, but it's normally a lot more polished than my sort of thing that I was messing around with there. It's generally recognizable from the little sort of cloud or logo in that top left corner and the standard Salesforce icons up in the top right. And the different sites constructed on top of it do tend to look very similar. You will normally recognize when you're interacting with one, and part of the time because you've been told beforehand anyway. For anyone who wants to play around with it like I started doing to learn this stuff, there is a free developer version that you can sort of log into and mess around with, set up your own stuff and interact with that and do a bit of practice. And lots of tutorials on YouTube. The Salesforce objects that I mentioned earlier are their way of referring to the data and the way they store that. It's conceptually, I like to look at it as being a bit like a spreadsheet. It's got this idea of fields and records which are kind of analogous to columns and rows within a spreadsheet. So each time you hear anyone refer to a Salesforce object, it's a bit like a spreadsheet. And the fields and rows that we'll be referring to in this are a bit like fields and records are a bit like the columns and rows. And within that, in that CRUD thing that I spoke about earlier, different users will have different permissions on different objects, different fields and different records. That's a way that people can customize Salesforce. There's a number of languages they can use. Apex is a thing that's kind of similar to Java in appearance, and it's a sort of object-orientated language, syntactically similar to Java, and you can use that to write APIs and other stuff that sits on top of the Salesforce cloud and helps you to build out any customized web application. In relation to acting, no pun intended, with the databases, the SOCL and UML are very similar to SQL in a regular database, and they have a similar syntax, act in the same way. SOSL'ed is a different query language, slightly different syntax and different behaviors to SQL. And the name, it stands for Salesforce Object Search Language. And it searches in a slightly different way to the SQL and, well, to the SOCL, which Salesforce gives this list of two sort of different sort of languages and the way you'd use those in different situations. I'm sure you can read faster than I can talk. I'm not going to read that all out to you individually. The main sort of 3 points at the start there are the reasons why you'd use the two languages separately. SOSL'ed would always be used in a search situation, but in a situation where you're searching in a much more general way, not sure which record it would be in or not sure which object you're searching, and it searches in a broad general way, but in line with your user permissions. And in the same way that if you're a C++ programmer, Java kind of looks the same at first, but it's different enough to confuse you still. SOSL looks a lot like SQL in some ways and completely different in others. It has this find keyword in place of selects, and then this different way of building up searches. The find keyword is universally there, and for your Salesforce clouds, those queries will universally search your Salesforce objects. SOSL injection, in the same way that SQL injection works, it's where a user's able to insert user-controlled data into one of those sort of sections of code within the Salesforce web app. And so in those, it would be where the user is able to control the search text or the search fields or one of those other sort of search parts of the syntax. And it's in any situation you'd normally encounter it, it would be in Java or Apex codes that's been used to write APIs or part of the web application that's within working with the Salesforce cloud. It's generally got information disclosure issues, but because the language doesn't modify data, you're going to be limited to information disclosure, seeing data that you're not meant to, interacting with data that's maybe sensitive. I've put that last statement there. It's theoretically possible for the results of that SOSL statement to be misused. I will say I've never seen that actually done in the real world. And this is the words from the SOSL injection page on Salesforce. Again, you can read faster than I can talk. I'm not going to read that out to you, but that's the main description that I found when I started trying to deal with the situation of finding these weird error messages and trying to work out how to exploit them in the work I was doing. After reading all that and finding out a bit more about SOSL injection, you're probably wondering how you can find out more, where you can get payloads, how to exploit it. And the answer that immediately I came to was that you can't. I Googled and started looking for payloads just to make my life easier online, and found myself in a situation where I couldn't find any further information on how to progress with what I was doing. So that's really the main point of this talk, is to explain for other people so they don't find themselves in the situation I was, of how to go about finding these. You do this in I'm going to talk about the code review situation, the web application testing situation, and API testing. And like any hacking or pen testing situation, it would be done in the standard sort of high-level methodology of just enumerating, footprinting what you're looking at, verifying what you've found, and then checking for the exploitability. And the reason I talk about verifying what you've found is that throughout the application or the API, you're going to find a number of search things. It's important to determine which ones are using SOSL, which ones are using SOCL, before you work out how to move on to try and determine the severity and the attack techniques that you'll use. in a code review situation, you generally find yourself looking at Apex code and very occasionally Java, where you might find, similar to web apps that you might have seen, the SOSL'ed statement being built up like this, where the SOSL'ed statement there, that string query string, is built up using inputs into the function to create a dynamic SOSL'ed statement that's then passed into the API or the web application. I'm told that there are some code review sort of commercial tools like checkmarks or Vera code that do locate the issue. I've never had access to one of those tools at the same time that I've had access to Salesforce, so I can't verify that. But as you saw earlier, the primary recommended defense on the Salesforce page is that escape single quotes function. We will be looking at when that does work and when it doesn't work later on. Also, the page we saw just was Apex code. What you would notice on the Apex code is that the search string is demarcated with single quotes. The other way it can appear in a code review situation is that search string there is held within those two curly braces after the find statement about halfway down. That is a SOSL'ed search constructed in Java. So you'll note from like both of the previous examples, as I said earlier, the find search is universally present. That is the thing you can search for to help you find this. And the quick and easy or quick and dirty way would just be to grep for finds. Like SQL, I should say, it's not case sensitive, but unlike SQL, it's a bit more sensitive about spaces. So in both these situations, you would have find that could either be uppercase or lowercase. The space afterwards is necessary. You can't have no space. And then either the opening quote or opening curly braces. I realise regexes are a bit of a dark art. That's my attempt at two types of regex to find that situation throughout any sort of code review that you're doing, which will search for find on a word boundary, either side of find, one or more spaces, and then either the opening quotes or the curly braces. So that should bring you back a full list of those in your code review situation, a full list of all the finds in there that should help you to identify all of the SOSL'ed statements, which you'll work through in the next stage. We'll go on to that in a bit, of finding out the level of injectability and what level of privileges that code has. Sticking with that high-level methodology of finding all the instances, if you're in an application testing or API test situation, part of the reason I didn't find this at first when I sort of initially started testing these websites is that these sort of things that you should have as part of your fuzzing catalog or corpus aren't typically within your sort of payloads that you would normally be fuzzing with. those four things I've got there are the literal payloads that you should use. So the quotes would be included as part of those payloads. And in any fuzzing of a web application or API, that will help you to find instances where the SOSL queries are being used. They will give a different response to the SQL or SOCL queries because although it looks to like you that the first three have 2 or more characters, those 2 character searches will return the error your search term should have 2 characters, which is because that SOSL error actually means 2 literal characters that are non-wildcards. And the quotes and the wildcard both count as part of the actual, sorry, the quote and the wildcard count as not being part of the search. The 4th search passed into the same sort of thing would bring back this result of either a completed search or anything that does contain the 2 characters you searched for, which would look like this in a web application situation. You can see the result of searching for the letter A in quotes, and that's a definitive sort of Salesforce SOSL error there. For an API test, you'd get back that HTTP 500 error, and it would be defined by the Salesforce error code apex error with the same message again in all of them about the search term requiring more than 1 character. As compared to that would be the result for 2As or something that's not there, you would just get the blank Salesforce page rather than the error. There's like various other things you can do, but they don't adapt quite so well to fuzzing that would indicate that SOSL's being used. And so you'd have to use that more in line with your knowledge of the application. And this stuff here will be more use later. We'll come back to it when we look at the exploitation. But from that point on, that you should have there a list of possible injection points, and that should have identified whether code review or app testing your starting points to work on. You've really just there identified where the SOSL searches are happening, and you can start to look at whether the injection would take place. In terms of what you're actually going to do with that injection, as I said, different users have different permissions. So if everyone is, which is a situation I've seen, if everyone is allowed to see all data, you can't really do much other than give the person responsible a self-satisfied lecture on good coding and what they should be doing to protect themselves. I will also say at this point, in terms of the app testing, you're far more likely to find it in APIs than in web applications. The Salesforce thing that helps you to build your own web applications is a no-code or low-code kind of solution that makes it almost impossible for someone to shoot themselves in the foot, and they won't be able to build their own queries quite so easily. For APIs, people have far more freedom, in quotes, to create those kind of dynamic dynamic SOSL statements that can cause injection issues. Part of the reason I keep talking about this user permissions stuff as well is that the Apex code that might be written to build up the APIs will typically run in the system mode, which would allow the API to query far more data than the user is normally allowed to, depending if it's been written with a lack of caution. And so if you find one of these situations, you might be able to read sensitive data or to read things that the developers might not have intended. One of the, I was going to say disappointing, it was very disappointing for me the first time I tried to exploit it. One of the sort of issues in terms of building up your own exploitation is that there's no comment character. So any injection you do will have to try and build up a syntactically correct sort of SOSL statement in order to avoid just an error message or getting nothing back. And additionally, as I said, there's limitations on what it can do. You can't interact with the shell in the way you could in PL SQL or T-SQL. Can't modify data in the same way you can with standard SQL. So if you're moving on from that, once you've got your list of things to identify and that clear idea of what exploitation actually means, you'd start to look at, first of all, you're looking at different instances of this in code review. You'd find any instances like this where a user-controlled string might be passed in and then used unsanitized in a query. That's a sort of basic example there, but it's more in a situation there which is not particularly exploitable, because you'd have to build up that syntactically correct statement from it. The other thing about the code review, I've discussed this earlier, is of course it can be enclosed in quotes or in the sort of curly braces, which again you'd have to look through to see what kind of situation you've got there. In terms of the risk levels and the things you can actually do in terms of injection, if you do see the use of that recommended fix, escape single quotes, you will find situations where it's not always safe and it doesn't give the protection you might hope for. So what we've got here is a situation that looks like it might be safe. The single quotes are escaped, and the user-controlled strings are then passed in after that minimal sanitization. There is a good reason why this is still exploitable. That second one there, the search fields parameter, would be passed into SOSL'ed's in clause, which allows you to choose various fields that are being searched. And that all fields, if this was like being populated from a drop-down list allowing somebody to search email or telephone number, and then you intercept it and say that was intercepted in burp and changed to all fields, that would cause that SOSL search, because of the way SOSL works of querying all objects, to go through and identify the search term in all fields. I've tried to clarify it a bit there. It's quite counterintuitive if you're used to SQL injection, in that being able to inject the search term isn't particularly useful, and being able to inject later clauses within the statement itself is far more useful to you from an attack point of view, and an information disclosure point of view. So always, as I said, check what's being done with any of those results and determine what could be any intended outcomes if it's intended for mass deletions or mass modification of records. That would greatly increase any risk associated with the thing you're looking at. As I said earlier, in the web interface, any searches that you do always run in user mode, and you'd only be able to see your users' records. It's a default situation with Salesforce that the Apex code and any APIs written in that will be running in system mode, and they'll be able to access a much wider range of data than the typical user can. So again, as part of a code review situation, you would want to look at whether user mode is being enforced on the searches. Not running in user mode isn't an issue in itself, because obviously there can be like a situation like, say, a help desk situation where each user has created their own help desk tickets, but you might want someone to be able to search all tickets. So you can't really use user mode as a silver bullet to control or prevent the actual issue itself. You can just use it as a way of identifying risk levels in any code review situation. For the application test, it's a fairly standard range of tooling or be usable. It's generally possible to test this stuff with Postman and Burp Suite if you're looking at any of these Salesforce kind of homemade APIs that people have built to interact with it. But you're restricted to doing that sort of footprinting I've spoken about earlier, of finding the SOSL'ed injection points and then trying to find a way of further, partly based on error messages and partly based on your own knowledge of the application, working out how you can exploit further from there. Testing sanitization is always done with the curly braces and the single quotes to see if it brings back some error message about, it'll bring back the standard Salesforce error message about an unexpected token. And that would indicate an absence of sanitization. And in a lot of cases, that won't allow you to carry out any sort of injection attack. You'll just be restricted to the slightly less satisfying situation of criticizing someone else's coding. In terms of the information disclosure issues, in terms of your web application testing, because we're looking for information disclosure, one of the ways of testing the APIs is to see if more information comes back from your injection attempts than it does within the web interface. Do you get different results back? And you can partly do that on some sort of response comparison for what comes back in the API, where we've got that injection into the origin points. And if that was something that was blocked within a web application, or if it's returning data that the web application doesn't, you've again got some vulnerability that you can report back and look at fixing. So we got there a API bringing back data that the web application doesn't. again, as I've said earlier, there's like some injection points are better than others. That counterintuitive example I gave earlier, it's deliberately contrived, and you might not find something exactly like that in a test situation. But if you're able to find yourself in any situation where you can manage these, I'll speak about another one in a minute, but these clauses later in the SOSL statement, that gives you far more of a scope for information disclosure, where you might be able to modify the fields being searched and search unintended or broader fields. The reason that fields clause is important, this is from the Salesforce page on that clause, is that the all fields sort of clause just automatically returns full scan of everything in system mode. There's another clause called returning, where it does a SQL style comparison within there. Again, this is partly the reason for checking for sanitization earlier, because that, I appreciate that's probably a bit small to read there. You can have a where clause that does an additional search comparison in there that could be a potential for abuse. Where the where clause would be used like in this situation, where it compares a test sort of inputs and then narrows down the SOSL search based on further inputs. So if you look at a situation where somebody's got an injectable where clause, this is probably far more similar to SQL injection that you've seen yourselves in web applications, where that final parameter, if it was unsanitized, you could do something similar to a SQL injection attack in that way. It might seem a bit tricky to have to work out which objects and records you're searching, but I'll show you in a few minutes. Salesforce does have a list of standard objects and records and that are present for every Salesforce cloud. So that there is not so much guesswork as you might think involved in that. But that would, if that situation was found in a code review, that could be one way you could use of injecting and carrying out a broader search than was intended. So to sort of show that attack in place, the original statement as intended by developers would be at the top, where the two user things passed in would be foo and test. And that would just bring back that much narrower range of records. The unintended attack produces that still syntactically correct payload and resulting in the syntactically correct statement, but to search a different set of objects and to bring back the records and fields from those objects. And as I said, the Salesforce web page has got a list of the standard fields in any cloud that you could use to sort of reverse engineer and sort of build up your own attack if you did find that situation. Obviously, the reason we all love breaking things, but obviously we're doing it to help people and to fix things afterwards. So we'll just talk about some of the things you can and can't do to sort of prevent any further damage or to prevent these from being easily exploited. as I said earlier, user mode, where it's feasible, will cut out any sort of information disclosure issues. There's places where that is feasible, and obviously places where it's not. If every user needs to search the entire product catalog, that query needs to run in system mode. Other queries can be run in search mode. Sanitization, SOSL and Apex do allow parameterized queries. So there is that colon operator. That's the same sort of fix that you would find in any parameterized SQL query, where there's no injection possible. There's just a sanitized search term placed into there. The escape single quotes we've already talked about. That does fix some issues, but not all of them, particularly when there's no quotes needed around the attack. And I would say avoid direct use of user-controlled string literals. So don't let an API pass in the name of the field it wants to search, or the name of the object it should be searching. And like in the same way you would block any invalid values, block SOSL keywords within search statements where it's feasible. So in terms of the safer statement construction, this here are like examples of unsafe, safer, and even safer. The top one is the injectable version of that SOSL query being built up dynamically in Apex code, where an attacker could inject into either search string or search field and cause some information disclosure. The next one down is similar to the thing we looked at earlier. It escapes the single quotes, which stops anyone syntactically breaking the statement, causing errors, or building up some longer search string, but does not stop injection into the search field. The bottom one is the parameterized query, which is a much more safer, sanitized version. It's what you will find in some cases if you have the fun of code reviewing this stuff. You tend to find a mixture of all three in use in normal code. But the safe option is the bottom one to always aim for. And again, moving on to the next recommendation, wherever possible, use user modes. Anytime a user should only be searching stuff that only they should be allowed to see. They should have a user mode applied to that search. And system mode anytime it's unavoidable, and it is for a search of the entire set of objects. And again, going back to that, never ever allow the use of string literals for the field names or the object names. It would be far better to, rather than let someone say search email fields, search telephone fields within the API, to just have a case statement at the back end that does something like this. The user or the API is substituting a digit that's translated at the back into the string literal that you will be putting in your search. That we've talked about there is just covered the SOSL injection, partly because it's so weird and esoteric and I couldn't find any way to do this, so I thought I'd help other people. In terms of the other languages that get used within Salesforce, typically if you're fuzzing or attacking these applications, typical SQL injection payloads will identify any injection in the SOCL and the DML. Although obviously if you're injecting into the DML, always best to be very wary of any or 1 equals 1 kind of situation and the mass deletions that would ensue. So I realise we've covered a lot there on what I imagine is probably a bit of an unfamiliar tool or unfamiliar system for a lot of people, compounded by a weird unfamiliar language. But the main things to go away with is, if you do come across this anywhere, information disclosure, leaking of sensitive information, the main issues to worry about. The injection points can weirdly, counterintuitively be far more exploitable or useful towards the end of the statement and outside of the actual search term. And it's always far more of an issue in any situation where users are restricted on what they can see. Far less of a concern where all users should be able to see all data. But this that we've had here is just what I've learned from trying to find out for myself. It really, if anyone wants to work further on this, I'd welcome any further input or other people's findings on this and what else can be done. Are there any questions?